recording. Okay, so just now we're going to talk about the best fit straight line equation, and the learning intention for that would be to be able to model real life situations using straight line and work out gradient and y-intercept, again using a graph, and form an equation for any straight line graph. So let's have a look where this could happen. The first thing first is you see here it says best fitting straight line. So it's a bit like we need to fit a straight line through all these points by trying to put the line in a position where it would be the best fitting place to put it. Okay. So this happens when, for example, you have data points being taken. They are not exactly proportional, but you measure a few points and you think, okay, it looks like I can fit a line through all these points. Okay, so when you plot data, especially in science, so in this case here, we've been trying to plot the weight in kilograms based on the height. Okay, so it could be some people. So now the first thing you will ask yourself is there a correlation between weight and height? By a correlation, we're trying to find if we can fit. So as we are increasing the height, you can see that the weight increases. Okay, so that's what they're looking for. So the first thing you would say, yes, I can see a positive correlation between all that data point. So the next question they might ask us is draw in the best fit line and find an equation relating height and weight. So what we've done here, we've tried to put a line, and as you can see, we've put some points above the line and some points below the line, and we've managed to go through a couple of points. And by going through a couple of points, we can see that we have 3 points above the line, definitely 1 point touching the line, and another 3 points below the line. So that's how they would go technically into trying to put a best fit line. Trying to put a line through so that you've got as many points above than you have below it, basically. Okay, so it's not a real science as to where you would put your line. So now, once you've put your line, as you can see here, they are going through a couple of points. We need to pick 2 points from that line in order to calculate the gradient. And once we've got the gradient, because we've got a gradient and a point, we should be able to write the equation of a line. So the first point picked here is the easiest point that you can find with any line, is that point called 0, 0, because our line passes through 0, 0. And the next one is another point where you've got 180 for the height and 70 kilos. So you would write 70, 180 because we always put X first and Y second. Okay, so once we've got our couple of points, we can do our gradient. So this is quite easy because you would pick X2, Y2 as your 70 and 180. Obviously, taking away 0 for X1 and taking away 0 for Y1 makes it much easier for us. Yeah. So M equal Y2 minus Y1, 180 take away 0, divided by 70, take away 0. And in this case here, I'm not going to put 18/7, but when you're going to be like dealing with real life type scenario, to make it easier for whoever's going to read back your answer, you can round to 2 decimal place your answer. So if I was to do this, I would just put 2 decimal place, even if they've not told me to do 2 decimal place, but because I'm not giving it as a fraction, it's always a good habit to tell exactly what you've done. So the real answer is 2.5714. To 2 decimal place, I can round it to 2.57. Yeah. And the next thing to do is, because we're cutting at 0, 0, the y-intercept is 0. When x equals 0, y equals 0. So now we can write our line as h equal 2.57 w plus 0, which is just 2.57 w. Okay, so now the next question they might ask us, that's strange, it went to D. Okay, so that should have been question C. What height is a pupil with weight who weighs yeah, who weighs 40 kilograms? So you replace W with 40 and you do 2.57 times 40. So you can look at the graph if you want to, or you can just use your new straight line function. So 40 should be something in the order of, yeah, yeah. So let's see, W equal 40, H equal 2.57 times 40, which is 102.8. Or you can round it to 103 centimeters if you just say with no decimal points. Okay, so that is the type of question you might get asked if you're asked to draw a best fit line. To be honest, to avoid too many different answers, they would probably put the line for you and say, based on the data set point, we've drawn a best fit line through as many points as we can. And then they would ask you the next questions. What, can you write the equation of the straight line? What height is a pupils who weigh 40 kilos? Or what is the weight of someone who is 120 centimeter, for example? Then that means you would need to replace the height with 120 centimeter and divide by 2.57 to give you the weight. So you can see the type of questions you may get asked. Okay. So that's what they call by best fit. Now let's see another example. This one, a survey was carried out on the value of cars depending on their age. Yeah. So if the question they ask us is, can you see a correlation? You would think probably yes. As a car get older, yeah, its value would start to go down unless you start to get into the 25 years classic type cars, then the value would go back up again. But if you're a salesperson, for example, and you only sell not classic cars, but standard cars, then you can probably say, okay, I've been selling these cars for the past, few years. I've been taking data points, and this is the kind of a graph that you would get. Okay, so let's see the question that we could come up with. First question is there a correlation between value and age? So yeah, we could say yes. By looking at these data points, we could probably draw a line through them. So these are the type of question you would get. Is there a correlation between, this data set point? So I can see a negative correlation. What they mean by negative is as you increase one of the parameter here, as we increase in years, the value decrease itself. So that's what they call a negative. The previous one, we had a positive correlation, if you remember, as you were getting taller, your weight was increasing. So here we've got a negative correlation. So let's draw a best fit line through them. So in this case, they've tried to put 4 points above it and 4 points below it. And by going through this point here, 5, 12. And the other point they've picked, as you can see, is the intercept, which is good, which is a 0.18 in value. So £18,000 for a brand new car is on average what they would sell them for. When the car is 5 years old, it goes down to £12,000. Okay, so they've not told us which car it is, it's just done a survey. Picking 2 points, I would pick the intercept 0.18, and we could have picked 5 of 12, but here they've picked 8 and 8, so £8,000 when it's 8 years old. So now let's find the gradient. 8 minus 18, take away 8 minus 0. So you should notice straight away that you've got a negative gradient, yeah? So whenever you're going to have a negative correlation, your gradient is going to be negative. Okay, so 10 over 8 or 5 over 4, which is just negative 1.25. But this time, because we've got an intercept, the intercept is c. Remember mx plus c. C is when x equals 0, and you can see the point there, c equal 18. Then you can write v, the value of the cars, as negative 1.25 y, the number of years, plus 18. Okay? So that's how we would answer this question. Equation relating value and year. Now, let's see the question. What is the cost of a car after 4 years? So you would replace y with 4. So negative 1.25 times 4 plus 18 in my calculator, 13,000. So after 4 years, you can see here, even by looking at the graph, we are between 12 and 14, which is bang on £13,000. Okay? V equals 13. The value is in number of £1,000, okay? So that's how you would answer this question. Now let's have a look into some other questions that are past paper questions. Again, best fit is given to us. That's usually what happens. They'll give you the line rather than letting you pick the line. So teams in a quiz answer questions on films and sport. This scatter graph shows the scores of some of the teams. A line of best fit is drawn as shown above. So film score, sports score. Find the equation of this straight line. Use this equation to estimate the sports score for a team with a film score of 20. So the good thing is they're using X, they're using Y. So we're going to look for Y equal mx plus c. Yeah? To make it easier for us. First thing first, we're going to pick 2 points. The 2 points have been picked for us. So we've got 15 and 33. 15 in X, 33 in Y. The other point is 9 and 21. Now you need to calculate M.
21 minus 33.
So Y2 minus Y1, 33 minus 21.
You make 33 Y2 because it's bigger. Nice.
Yeah, because it's easier for me to deal with positive fractions, but basically if you had make it the other way, you'll get a negative divided by a negative. But the good thing is now that you're used to straight line, you know that your gradient should be, if you get a negative gradient, somewhere you've made a mistake, okay? So yeah, I've picked it that way so that it's just to make my life easier. 33 take away 21, that's 12. And the other one we said was 15 take away 9 divided by 6.
Yeah.
So how many 6 can I fit into 12? Yeah. How many 6 can I fix into 12? 2. Okay. So I know what M is. M equal to, I need to find C. So if they had given me what that point was, I could have found C. But look what they've given me. If I do 2 times 9, what do I get?
18.
18. And where is the point? It's gone up by, from 18, you went up by 3
21.
to get 21. So straight away, you can see what you need to add to 18 to get 21. So that's one way of you finding what C is. C would be equal to 3 if you were to do 2 times 9, 18 plus 3 would give you 21. Or you can just use the old-fashioned AB if you wanted to. Y minus B equal mx minus A. So we could do that. That should give us the same answer eventually.
Minus 21. Yeah.
So let's pick 921. So 9y minus 21 equal 2x
Minus 9.
minus 9. So that's 2x minus 18.
18 comes across, 21 comes across as positive.
Yep. So if I add plus 21 on each side, I end up with y equal 2x minus 18 plus 21. And that should yield 21 take away 18 is just 3, right?
X plus 3.
And we've confirmed that using this technique, knowing that if you're at 2x, 2 times 9 is 18, you need to add 3 to get to 21. It does work. Now you can check that if I use 9 for x, 2 times 9 is 18 plus 3 is 21. My point 921 belongs to my line. And that is your answer there. Okay. So now if I've got a team with a film score of 20, so film score, remember, is x. So if I put
2 times 20, 40,
y equal 2 times 20 plus 3, and that'd be 43. Yeah. So that would be your answer to the second question. So B is a mark of 43 for the sports score, and A is what we've done here, finding the gradient and the equation of the line. So that would probably be 3 marks and a mark, so that'd be 4 marks for a typical type problem where it's just using straight lines. Okay, so even if you couldn't remember y minus b equal mx minus a, you can just use a point and just say, I've got y equal 2x plus c. So let's say I always remember y equal mx plus c. So y is 2x plus c. I'm looking for c. And that should pass through 9 and 21. So 21 equal 2 times 9. Sorry, 2 times 9 plus c, which is 18 plus c. What do I need to add to 18 to get 21? So you could have got it here, c equals 3. That's why I tell my student, don't panic if you can't remember that y minus b equal mx minus a. As long as you remember the mx plus c, it should get you out of trouble. Okay. Yeah, so I've left quite a few of these type of past paper question in this set of slides. So if you want to practice some of them, try them, give it a go. It's a typical type of, real life context type questions that you may get during a, so this is like the sales of umbrellas as temperature increases. So you can see you've got a negative correlation. You'll sell less umbrellas when the weather is nice. And then you can answer this type of question. The next one, taxi fares. Yeah, so that's the past paper question. A taxi fare with regard to the miles traveled. Okay, and I've put some links here where if you wanted to practice question without answers and question with answers, that you can just hit those links and that should take you to some free good pages. And again, some straight line type question. There's a 20 odd questions there that you can just use to practice. Okay. And let me know if you do them, and if you get stuck with one, just tell me slide number such. I'm struggling with this, so I'm struggling with that. Okay.
Yeah.